Okay, so let's get stuck into the exam 2 problems. So not the multiple choice, the analysis questions. Whoa. Okay, so there's question 1, and what we needed to do was find f dash x. We're probably going to use that function a bit, so I'll start this with a define f of x equals x to the 5 take away 4x to the 4 plus 4x to the power of 3. Let's diff it. Okay, has 3 stationary points with 1 at the origin and another located there. Find the coordinate of the other one. Okay, so for 2 marks, you really need to show some working out for this. Okay, so the way we get coordinate points, stationary points, is we let the derivative equal 0. So we write that down, and we're going to go solve x equals 0 for x. We're going to say x equals 0, x equals 2, x equals 6 on 5. Need x equals 6 on 5. Therefore, f of, we're not going to do it therefore actually. So need x equals 6 on 5, so we'll do f of 6 on 5 to find the y value. 3, 4, 5, 6. So it didn't take long for the numbers to get ugly, but that's all right. Got a calculator. So there's the coordinate of the other stationary point. So it's 6 on 5. So like that's that one there. 6 on 5 is the x value. Okay, and the y value is that one there. Okay, the point P is located where f of x equals f dash x, near the local maximum. Determine the coordinate of point P. So that's that point there. So it's near the local maximum. What we'll do for this one is we'll again diff the function and solve that. So its derivative equals the original function for x. Probably get a number of solutions for this one, but the one we want is what's got to be x equals 1. Okay, so for 1 mark, we don't really need to show any working here. We can just go, it's going to be at 1 comma f of 1, and f of 1 is 1. So point P is at 1 comma 1. Label the coordinate. I just did that. Okay, that's convenient. On the Cartesian plane on the previous page, the same axes as that, sketch the graph of f dash x, labeling the coordinates of the x-axis intercepts only. Okay, so what's going to happen is derivative graph will have 0 gradient there, 0 gradient there, and 0 gradient there. It's got a positive gradient, so it comes in there. Then it's got a negative gradient all the way to there, a positive gradient rather. So it's going to go positive gradient up to this point here, and then it's going to have a negative gradient. Okay, so it's going to go something like this. It's got to go through that point because we know that's when they're equal. So it goes negative, then it comes back up again, 0 gradient, and then a positive gradient, so something like that. Right, so the shape wasn't all that much of a concern. It needed to go through the point we just found, which was 1, 1, and it needed to have these 0 gradient points in roughly the correct spot. So 0, 0, oh that's stupid, that was just labelled. 6, 5, 0, and 2, 0 is already labeled. Labeling the coordinates of the x-axis intercepts only. Yep, done. State the values of b for which the graph of f of x plus b will have only one x-intercept. All right, so what we're doing basically is we're lifting this original graph either up or down, okay? And what we're trying to do is create a situation where it intercepts only once. So what we could do is start lifting straight away, all right? So if we basically lift it, so we could say quickly here that the answer to this is b greater than 0. So when b is larger than 0, i.e. when we translate it vertically more than 0 units, like 1 unit, 2 units, then we're going to get only one x-intercept. It'll be along here, okay? Now the only other thing that we need to consider is actually if we bring it downwards. So if we bring it down far enough so that this goes to this point here, basically this part here then becomes the only other x-intercept as well. So we need this answer here as well. Okay, so we're going to say b greater than 0 and b less than 3, 1, 4, what was it? 3, 4, 5, 6. It's really messy. 3, 4, 5, 6 over 3, 1, 2, 5. Wasn't well spotted, that one, but yeah. A good way to do these problems, if you want to explore how transformations affect them, is we take our original function, go over to the graph and table screen, and paste in your function. And what we're doing is we're doing a plus b on that, and you can actually sketch a parameter graph and explore what the changes have. So you notice that this is when b is equal to 0. So this was the standard graph that we had. So when it's larger than, notice that we only get the one x-intercept there. But if we go the other way and we go down far enough, that we only get the one x-intercept here. How far do we go down? Well, it's beyond the y value of this stationary point here. So pretty tough problem there. It actually turned out to be tougher than we wanted it to be honest. Okay, the tangent to the graph of f of x at x equals 1 is given. It's pictured at right. The normal at x equals 1. The tangent is y equals x. Tangent is shown. The equation of the normal is that. Well, you can kind of see that if the equation of the tangent is y equals x, then it will have a gradient of 1. The normal is going to have a gradient of -1. So it's going to be negative x plus the y-intercept is 2. So that just makes sense. But let's not assume anything. Okay, so what we'll do is we've got f dash x, and we want to do f dash 1. We want to find out what the gradient is at x is equal to 1. Okay, so what we're going to do is pop that into f dash x. So f dash 1 is equal to, so let's go back into main. Now note the thing about parameters is when you use them, that b value will be hard coded in there. So it's best to, I think, as you come back, go action command delvar and get rid of the value, whoops, not BB, B. And now if you use B in the future, it'll come up as just B and not -5. Anyway, what we'll do is we'll diff f of x and ask it what its gradient is at x equals 1. Now the answer should be 1. Yep, and it is. F dash 1 equals so this is a show question, so I'd be more inclined to kind of put those values in. So 5 times 1 to the 4 takes 16 times 1 to the 3 plus 12 times 1 to the 2 equals 1. Right, so show what you're actually doing. So therefore, m tangent equals 1, and m normal equals -1/1, which is just -1. All right, so now we're going to choose a point. So let's choose the point, or a point that we know is on the graph, which is 1. So we know that f of 1 equals 1. We were told that before, is on f of x curve. So let's just choose which form we want to do it. Y take y1 equals m take x1, y take 1 equals -1, x take 1, y equals -x plus 1 plus 1, y equals -x plus 2 as required. Is that what I was supposed to show you? Yep, yn. Let's just make sure it lines up exactly. Determine the area of the triangle bounded by the tangent, the normal, and the x-axes. That's this area here. So, 1 mark. Okay, so from year 7, area equals half times the base times the height. So the height, I know that that point there is 1, 1. So the height is 1. The base is 2, so half of 2 is 1, just 1. So the answer to this is 1 unit squared. The graph is translated horizontally 1 unit in the positive direction to become g of x. So the best way to do these problems, girls, is to simply, when you want to translate 1 unit in the positive direction of the x-axis, we're going to go f of x take 1. So let's drop x take 1 into the function, and we get that. Let's just run a simp on that. Yeah, it comes out nice and pretty. Okay, so there's g of x. Determine the area of the triangle bounded by the x-axis and the tangent at g of 2 and the normal at g of 2. Okay, so what happens is g of x is formed by moving this whole graph 1 to the right. So this point ends up at this point. And it's basically the same triangle drawn, but 1 unit over, which means it's going to have exactly the same area. Okay, so a bit of a cheeky question by Mr. Miller there. 1 unit squared. Okay, the new STEAM Centre will provide 2 identical display windows situated on a wall to show off exceptional student work. The 2 windows are equally spaced so that all of the dotted lines are 2 meters long. The total area of each window is to be 12 square meters and x is the height of the window. Okay, so is a window, so area equals x times y. We know that the area of each window is 12, so that's 12 equals x, y. Y is equal to 12 on x as required. Length of the wall in terms of x. So this is the length of the wall in terms of x. So we know that y is 12 on x. So that's another way of writing that, I suppose. So y is 12 on x, and what have we got? A 2 and a 2 and a 2. So it's going to be 6 plus 2 lots of 12 on x. So 2 plus 2 plus 2 plus 12 on x plus 12 on x. So that's going to be equals 6 plus 24 on x. Find the height of the wall in terms of x. So it's going to be just x plus 4. Okay. Right, hence show that the area in square meters of the wall excluding the windows can be modeled by that. A of x equals. Okay, so what we've got to do is do length times width, take away the area of two windows, two lots of area of windows. Okay, so this is the area of a window, which is 22 lots of 12, which is 24. So the length times the width. Now the length is 6 plus 24 on x. Plus 6 times the width or height is going to be x plus 4. Take away two lots of 12, which is 24. Okay, all right, let's just see where this is going. So show that, hence show that. Okay, so that by that is going to be 24. That by that is going to be 6x. That's going to be 4 lots of 24. So plus 96, is it? 26 on x. What haven't I done? Plus 24. Take 24. Those will cancel out, leaving us with, yep, there it is, 24 plus 6x plus 96 on x as required. Can't spell required. The maximum area of the wall is 200. Okay. Suitable domain. So what we'll have here is like, we're going to have a function. I wonder what that looks like. All right, let's just, so maximum area is 126. So we'll go a of x equals 126. Okay, so let's jump on and define f of x equals 24 plus 6x plus 96 on x. Solve f of x equals 126 x. X is equal to 1. X is equal to 16. Therefore, x is an element from 1 to 16, including those endpoints, because we can make an area of 126. Okay, find a dash x, diff f of x. For one mark only, a dash x is equal to 6x squared take 96 all over x squared. Determine the minimum area of the wall. So that's just a dash x equals 0 for 3 marks, by the way. So we've got to do a bit of work here. So solve x equals 0 for x. X equals -4. X equals 4. But x is greater than 0. Therefore, x is equal to 4. Now what we'll do is we'll go a of 4 equals, so we're going to shove 4 into the area function to work out what the minimum area is. So f of 4 equals 72. Therefore, 72 meters squared is the minimum area. Determine the minimum width of the window. So we worked out the width earlier, I believe. Length. The window. So this is x times y. So it's just going to be 12 on 4. So equals 3. Therefore, it's going to be 3 meters. So that means that that's going to be 3 because x is equal to 4. That makes the 12. Okay, sketch the graph. Okay. Now, let's go check out what it looks like. So let's, because we got areas, let's go up to 300. And max, when was it? 4 and -4. What was the points? It was 16. Let's go to 20. This should get us a look. Okay, there it is. Okay, so we know that, so we've got 4, 8, 12, 16. We know that 16 was 126, I think. 16 was 126. And 1 was 126. And what was 4? So the stationary point was 472. So 72, that's a bit under halfway. So let's go 72 there. Okay, so what our function does, it's sort of asymptotic there, swings in through there and flicks up to that point there. So that's going to be 16, 120, what was it? 126. 1, 126 and 4, 72. State the range. So it's going to be y is an element, lowest value is 72, highest value is 176. Okay, a group of lab techs were attempting to model the decay of newly discovered radioactive substance called miltonium. Okay, so this is the exponential model that we want to follow, base 2. So there was initially that, after 9 days there was that. Right, 2 equations to show how they determined that A was equal to that, K was equal to that. So this will just involve us going, not M of T, so we're just going to plug this. So initially, so that's, how are we going to do that? After 9 days, I can see that one. So that's going to be the amount So after 9 days, or t is equal to 9, so we're just basically subbing that for t and that for m of t. And I think, yeah, let's just do this. Equals a times 2 negative k times 0. So these are the 2 equations that we would use to determine. So we could solve these simultaneously, or we could use initial value to find k. In fact, a lot of students showed k, which I certainly accepted as a correct answer. Okay, using the model, blah, blah, blah. Okay, so let's go to calc, define x equals 9.2500 times 2 to the power of negative 0.0486 times x. Okay, how much of the miltonium decays in the first hour? Correct to 4 decimal places. Okay, so hours, and the question has time in days. So in the first hour, is 1/24 of a day. So that's going to be m of 1/24. So let's slam that into the function. So so how much of the melatonin decays in the first hour. So that says how much is left. So what we need to do is grab the original amount, which is 9.2500, and remove that. Four decimal places, 0.012, what is it, 30? 30. What is it, grams? Okay, the half-life of a substance is the time it takes for half of it. Find the half-life. Okay, so what we would do is we're going to go, so here's our equation here. So let's do 9.2500 over 2 equals 9.2500 times 2 to the negative 0.0486 t. T is equal to. Okay, so what we'll do is go solve f of x equals 9.2500 over 2 for x. Okay, t is equal to 20.576131 ... Okay, so now to convert that to, so it's going to be 20 days, and this to get hours, so it's going to be like half a day, a bit over half a day, times 24 hours in a day. So that's going to be so 13.8 hours to the nearest hour is going to be and 14 hours. The lab techs also receive a sample of another one called Ralphington. Sample has, okay, so for this one here, what we'll do is we'll go m of t equals r of t. So we want to let them be the same. So on the calc, solve f of x equals so that's the initial value, 5.2700 times 2 to the power of negative 0.0309 x, comma x. So 40, what is it, 48. So t equals 45.8559 ... That's going to be 45 days and times 24 and 21 hours. So to get that, we'll stick, so this is the time when they're going to be exactly the same, so we'll pop that into f of x. So we'll go m of 45.8559 ... equals 1.9736 ... therefore 1.9736 grams.
Okay, and on to the last problem. So question 4, Olivia has just received an early Christmas present, a brand new slide. Mr. Miller did his research in advance and determined an equation that models the profile of the slide to be this. So this equation represents this, x and y are centimeters. Okay, so to make the slide more exciting, he adds an extra section onto the edge of the slide, or end of the slide rather. He called it section B, and it's modeled by this equation. So show that section B will attach. So probably the best way to do that is to do g of g of 6 and find out what it equals, and do f of 6 and find out what it equals. Okay, so g of 6 and f of 6, and we know that both of them are going to equal 10 and 10. So g of 6 equals f of 6, therefore slide is continuous or will attach. Okay, sketch the graph of section B on the axes, labeling their endpoints with coordinates. Okay, so let's have a look. We've got a period of 2 pi over pi on 4, which is equal to 8. All right, so this is going to be amplitude 5 is 15. So there's 15 up. So it would be 5, and our scale is 2. So every 2 we get 5 up. So there's 15. Then we go to 20. To 12, I think it is. Yep. So that's that part there. So we're going to go like that. So we've got 12, 15 at that endpoint, and 6, 10 as we established. And this one here, the turning point is going to be 10, 20. Okay, state the coordinates of the maximum point in section B. Well, it's just, 10, 20. All right, find the height of the slide at the following points. Okay, so x equals 3 is going to be f of 3 equals, and x equals 9 is going to be not f, but g of 9 equals. And I wonder whether we'll be able to do this just by sight. So f of 3, 2, 3. No, we won't. So what we'll do is we'll go ahead and define, I think. Should we define them? No, we don't need to define them because we're not going to use them next. So we'll just go x is, what was it, 3 times 3 all over 6 plus 20. It's just 20. Oh, yeah, okay. Probably didn't need to type that into the calculator. So that one there is 20 centimeters. Meters? Centimeters. 20 centimeters, doesn't seem like that much. Anyway, and 9, yeah, probably going to have to type that one in. I think that's a clunky value. So g of x is here. So we got 5 times the sine of shift pi multiplied by x, which is 9 over 4 plus 15. And I presume it's an exact. Yep. So it's going to be 5 root 2 on 2 plus 15 cm. After the success of section B, Mr. Miller thinks he can replace the original slide with one of his own designs to make it more exciting, he comes up with a new design code name section A, but decides that it'll only be more exciting if it's steeper than the original slide. So the idea is that we want steepness. Okay, steeper slides are obviously more exciting for Olivia. So to compare the steepness of the two sections, you'll need to compare the graph of the gradient function. So here's our original slide, and here is our new section A. So by analyzing the graph of the gradient of the original compared to the new design. So determine the x coordinate of the most negative slope. Okay, so the way we're going to do this, there's probably two methods to do it. So let's note down what f-x is and h-x is for each of these functions. Okay, so the way we'll do it is we'll diff 10, we'll diff that, x gives us that. So it's -5 sine x pi on 6 multiplied by pi all over 3. And what we'll do is, so that's going to be over the domain 0 to 6. So let's copy that, go into graph and table, and paste it. Let's just check out the gradient graph. All right, so that's where it's most negative. Okay, so what we'll do is we'll try and we'll do, actually, do you know what we'll do? I reckon even better than that is let's go to, back to main, and we'll run an f-min. So calculation f-min on whatever's in the answer slot between 0 and 6. So most negative slope is at x equal 3. All right, now let's do the same thing for this one. So we'll get the derivative function. So diff 5 over 27. So let's write that down. So we've got 5x squared take 30x all over 9. And we'll do exactly the same thing for that. So f min okay, so most negative slope is also at x equal 3. Right, so basically both of these have their most negative gradient or the biggest negative slope at x equals 3. So hence or otherwise determine the slope at the x coordinates found above. So f dash, or actually f dash 3 and h dash 3. So what we want is the gradient at both of these points. So we just found out the last one, so that's going to be -5. And the other one is going to be -5 pi on 3. So that's what the gradient is for the first one and the second one. Using this information, help Mr. Miller determine which function he should use, provide some justification. So this is -5, and this value here is approximately -5.23. All right, so what we're going to say here is the gradient, no, we're not going to say that, the downward slope for f dash 3, which is negative 5 pi on 3, is steeper, so it's got a steeper slope when compared to h dash 3, which was negative 5. Thus, to make a more exciting slide, Mr. Miller should use f dash x. Okay, so the original is going to be the better one because it has the more negative slope. All right, and I think, yep, that's the exam.